So, arithmetic calculations, of course. So, well, you can say that the computer is just a fancy calculator, but it's like, that's right. Doing mathematical numerical calculations, that's one task that they can do very well. So, well, let's just do that. First of all, the numbers, well, it's just data literal. So, when you want it to evaluate, it just evaluates to itself. It's just a piece of value. Okay, so let's talk about the basic arithmetic operations like adding numbers together, and that's this is slightly different. So 3 plus 2 is 5, but the operator is at the front, and yes, indeed. So the idea of Clojure and in particular and Lisp in general is that we want to have this uniform syntax, uniform way of saying that you have a list, and the first one is the function or the operator, and then you have the argument. Okay, so this may look unusual and it's unfamiliar, so it might feel difficult, but that's not the same thing. They are not the same thing. Unfamiliar and difficult, they are different. Okay, so it's very easy to get used to this. And you will see that there are actually a couple of advantages here. For example, if you need to add more than just 2, well, you still use the operator only once. The trick is, if you find this difficult to read, the trick is that you put the operator between the arguments. Okay, so it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Okay, but it's like this way, it's a lot simpler to say that. And of course we have multiplication as well that evaluates to 6. So now it's like let me show a funny thing. So if I say that let's just do plus first. So what does this evaluate to? And that gives 2. So it's like we are adding numbers together and one is missing, so the default is 0. And even more surprising is this one. This evaluates to 0. If you give no argument to the addition, the plus operator, you get 0. And well, why is this so? Why is it just it's not a meaningless expression? Well, the reason is that you can go to abstract algebra, and abstract algebra will tell you that, oh, with regard to addition, 0 is very special. That's the neutral element or the identity. If you add anything to 0, then you get that thing back. In a more practical way, you can think of it as that, if your task is to add numbers, then you might receive those numbers in a collection. Maybe someone is sending it over the network. And what happens if someone sends you an empty collection? So what are the choices? We can just crash, or we can do very elaborate checking whether the input data is fine, or we have a sensible default value, and abstract algebra gives you that one. So once you have this idea, maybe it's not too difficult to figure out what is the well, it's actually on the screen because it comes up in the documentation. So what's the value for this one? The multiplicative identity is 1. But of course we have other operations, and that's that notation might be a bit more troublesome for that one, because how do you read this? Again, the trick is just put the operator in between. So this will be 2 minus 3 minus 4, and that's well, yeah, it's 2 minus 7, that's minus 5. Okay, that's how it works out. And also you can do it with division. Let's say, oops. So this evaluates a 2 because 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. Okay, and another thing, which is an advantage, is that you don't have to deal with the precedence, the operator precedence. That if I write this, if I'm adding 2 to 3 times 4, which happens to be 14, there is just no ambiguity. But it's like, okay, if you come here, it's like 2 plus 3 times 4. Okay, you can read this in two different ways. It's 2 plus 3 times 4. This would be 5 times 4, it would be 20. Or you read it the other way around, as we calculated as 14. So you need to add the parentheses anyway. So it's actually this prefix notation, operator first, is not ambiguous. Okay. So what if you need to have more complicated operations and like trigonometrics, exponential functions, and mathematical constants? Well, since Clojure or Clojure script is a hosted language, and every language, every general purpose programming language contains all those mathematical functions, well, what Clojure does is just drops down to the host language, and you can find them there. So one can simply go to the Java language documentation, and you will find it in the class math, all the constants that are defined and all the functions. Well, they call it methods because, well, that's Java's way of saying that. And well, you can look at everything you need for mathematical calculations. And of course, if you are in Clojure script, then the underlying language is JavaScript. So let's just go there. Well, I'm not sure whether this is the right page for the documentation. I'm not really familiar with JavaScript, but it's okay. This is like Mozilla website, so probably it's a good source. Anyway, here are the constant defined and all the methods as well. Well, it's sort of a similar set of functions. Of course, if you can't find the thing you need here, well, that's a good opportunity for do some programming. So how to access that? Well, you can just have say here is pi, and we can calculate. So that's just a constant, and we can calculate, let's say, the cosine of 0. That has to be 1. Okay, so this is how you can access these functions.